All right, specific type of quadrilateral that we need to talk about are parallelograms, and parallelograms are important because they have a lot of properties that go along with them. So whenever we're talking about parallelograms, all of these properties come up from either the definition or one of these four new theorems. So the first thing we're going to look at is the definition, and the definition of a parallelogram is that it is a quadrilateral, is a parallelogram if and only if it has two sets of opposite sides that are parallel. So two sets of opposite sides that are parallel. So this, by the definition, means that anything that is a parallelogram, the opposite sides are always going to be parallel, and there's two sets. The next thing is theorem 6.2, which gives us our first important property that comes from a theorem. And so if something's a parallelogram, then automatically the opposite sides are going to be congruent. The next theorem is 6.3, which says that if a quadrilateral is a parallelogram, then opposite angles are congruent. So in theorem 6.4, now that we know that our opposite sides are parallel and that our opposite angles are congruent, if a quadrilateral is a parallelogram, then the consecutive angles, meaning angles that are side by side, consecutive angles are supplementary. So this means that angle 1 would be congruent to angle 2, not congruent, sorry, supplementary. Angle 1 is supplementary to angle 2. Angle 2 is supplementary to angle 3. Angle 3 is supplementary to angle 4. And angle 4 would be supplementary to angle 1. So any set of angles that share a side, those are going to be supplementary. They're going to add to 180 degrees. And our last big property for parallelograms is that whenever a quadrilateral is a parallelogram, then the diagonals bisect each other. So the point where they meet, that is the point so that each piece of that diagonal, so this piece and this piece for that first diagonal, those two are going to be congruent. And on the second diagonal, the two pieces are going to be congruent, but it does not mean that they are congruent to each other. It also doesn't say anything about the angles, so this is just purely those lines that cut through, and whenever they meet, the two diagonals meet, it's exactly halfway for both lines. So overall, here's all the information that we have. So we have that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So we're going to use this to kind of figure out some other relationships. So here, we're given this parallelogram. We can tell because it's marked that opposite sides are parallel, and we're given a couple measurements. So we know that GK is 8 and KL is 6. So using this, we're going to figure out what the length of line segment JH is. So if I'm looking at JH, its opposite side is GK, and so since it's a parallelogram, those are going to be congruent. So since GK is 8 units, JH is also going to be 8 units. So JH is 8. And the next thing it asks about is it wants to know about LH, which is this segment. Now that's a piece of the diagonal. So the other piece of this diagonal is KL, which was given to us to be 6 units. So LH will also be 6 units because they're congruent. So by bisecting, the two pieces are congruent. So we can find those measurements since we were given the corresponding pieces. In example 2, we're given 4 pieces of information, and then we're going to use those to find these other things. So first, let's go through and label the pieces of information that we know. So we know that the measure of angle VWX, so VWX is this entire angle down here. That entire angle is 120 degrees. Then we're given that the measure of angle UVZ, so since Z is this point in the middle, UVZ is just this top part of that angle, and the top part of that angle is 25 degrees. we're given that line segment XU, which is this side over here. XU is 15 units and UW is 28. So UW, which is this entire diagonal, that entire diagonal is 28. All right, so let's look at what pieces we're trying to find and what we're going to use to help us figure that one out. The first thing that we need to try to find is segment UZ. So UZ is a piece of this diagonal here, and the entire diagonal is 28. So since the diagonal is bisected, that little piece of the diagonal is going to be half of the entire thing. So to find the length of UZ, we're going to take 28 and we're going to divide it by 2 to find that the length of UZ is 14. So this piece is 14 because it's half of the entire diagonal. The next piece of information we want to find is side VW. So VW is here, and opposite of that side is side UX. So those are going to be congruent. So since UX is 15, UW will also be 15. Next, we want to find the measure of angle VUX. So VUX is the angle up in the top left corner. And so this angle is going to be congruent to the opposite angle, which is at W. So that angle is 120 degrees. That means that this angle up here will also be 120 degrees. So going back and filling in the theorems that we use there just to make sure that we're knowing why we can use these things. The opposite angles are congruent. That is because of theorem 6.3. Opposite sides are congruent is what we used in the previous one. That was theorem 6.2. And finally, the diagonal was bisected, and that came from theorem 6.5. So all of those theorems allowed us to figure out those pieces of information. The next thing we are going to look at, we want to find the measure of angle UXW. So UXW is this angle down here. So if we look at the opposite angle, it would be congruent to that opposite angle, but all we know is one little piece of that opposite angle, which is the 25-degree part. The angle does not apply, like the bisector theorem does not apply to the angles. It only bisects those two diagonals. So we can't really use that piece of 25 information. But we can use these consecutive angles. So theorem 6.4, the fourth theorem told us that the consecutive angles are going to be supplementary, and supplementary means that they would add up to 180. So to find the measure of angle UXW, we could do 180 minus one of those consecutive angles, which is 120. And we would find that the measure of angle UXW is 60 degrees. So now we have that piece of information, that angle UXW is 60 degrees. So those first four pieces of information came directly from the theorems. Our next two that we have to find, we're going to have to use a little bit of reasoning skills. So the first angle that we're asked to find is angle WXZ. So if I map out where WXZ goes, so WXZ, that is this little angle down here. So it's not the entire diagonal, and that diagonal does not bisect the angle there. But we do know from the definition that opposite sides are parallel. And so if we think about extending this out and kind of using some past knowledge about parallel lines, opposite sides are parallel, and then this diagonal can be thought of as like a transversal. So what we're looking at here are the interior angles that are kind of forming this Z shape. And so those angles are called alternate interior angles. So this is a way past unit, but alternate interior angles are congruent. So since this angle up at the top is 25, this little piece down here is also going to be 25 degrees. So we used that little piece that we knew to help us figure out the other piece. Our last thing that we need to figure out is the measure of angle WVZ. So WVZ, that's this other piece over here that makes up the whole angle up there at the top right. So in a previous question, I was asked what the measure of angle UXW was, and that angle was 60 degrees. So since this angle at the top right is also going to be 60 degrees, I can use that angle sum and the other piece that I know of 25 degrees to figure out what that new little piece that I'm trying to find is. So I'm going to do 60 degrees for the entire angle minus the 25 degrees for the piece that we already knew. And we'll find that the measure of angle WVZ is 35 degrees. So a lot of these old things can come back and help us reason our way through finding some of these missing parts. All right, in example 3, we're going to find the value of x and y. So notice by the way that this is set up that our two sides that have x's in them are opposite of each other. So theorem 6.2 says that opposite sides are congruent. So using that, I know that these two sides are going to be the same measure. So to figure out the value of x, I'm going to set those two expressions equal to each other. So I have 3x plus 7 equals 5x minus 5. And I'm going to solve that to figure out what x is. So first I'm going to subtract 3x from both sides. So that leaves me with 2x. And then I bring down everything else. So to get the x by itself, I'm going to add 5 to both sides. And 7 plus 5 is 12. So I have 2x equals 12. I'm going to divide by 2. Oops. And I get 12 divided by 2, so x is 6. So the value of x is 6. And that's the number that if I plug into both sides will make them equal. To find y, I'm going to do the same thing because those are set up as opposite sides. So they will also be congruent. So I have 2y plus 3 equals y plus 9. And I'm going to solve by moving things around and getting the y's together. So subtract y from both sides. 2y minus y is 1y. So y plus 3 equals 9. Then I'm going to subtract 3 from both sides. And y equals 6. So 6 is the value of each of those variables. But whenever you plug it in, you'll see that the opposite sides are all the sides are not congruent. They still come out to different measures. So if I plug in this 6 for y, I have 6 plus 9 for the expression right here. 6 plus 9 is 15. So that means that both of these sides would be 15 units. And then if I plug it into the other sides, x is 6. I'm going to plug it into the top. So 3 times 6 is 18. And then 18 plus 7 tells me that this side is 25. So not all the sides are the same, even though the variables are the same. They're still different lengths, but opposite sides are congruent. All right, in example 4, we were given that in parallelogram ABCD, the measure of angle C is 105. We weren't given a picture here. So I like to draw things out and see where everything lays. So if I think about this, first, the important thing about this is I need to know how to name quadrilaterals and larger polygons. So the name tells me how the shape is set up. So whenever you're naming a polygon that's bigger than 3 sides, you have to pay attention to what things are connected. So if this is named A, B, C, D, you choose a vertex for A. So if I choose that this vertex is A, I need to either go around this way or the opposite direction to name the rest of the vertices. So if I start at A and I want to go this way, that means that this next one is going to be B. Then I have to keep going down the side to get to C. And finally, I'll round back around and find part D. So once you get to the end of the name, you should end up back at the first letter. So make sure that you're naming polygons. If you're drawing yourself a diagram, make sure you're naming it around the shape. Don't go through the shape. So you can't go through the middle. So I couldn't go A, B, C, D. All right, so with this, now that we've got it all set up, the measure of angle C is 105 degrees. So I'm going to find the other angle measures using some of these properties that I know. So mainly the angle properties are theorem 6.3, which says that opposite angles are congruent, and theorem 6.4, which says consecutive angles are supplementary. So the easiest one is the opposite angles being congruent. So opposite of angle C is going to be angle A. So since angle C was 105 degrees, angle A will also be 105 degrees. So the measure of angle A equals 105. I still need to find angles B and angle D. So if I can find one of them, then I'll know them both. So these two will be congruent. And also we have theorem 6.4, which says that the consecutive ones are supplementary. So next what I'm going to do is I'm going to take 180 and I'm going to subtract 105. And that leaves me with 75 degrees. So the remaining two pieces of this parallelogram have to be 75 degrees each. So the measure of angle B is 75 degrees. And the measure of angle D is also 75 degrees. All right, in our last example, we are given the graph of a parallelogram. So we're told that this is a parallelogram, and we're going to verify these different properties. So the first one says, use the slope formula to show that opposite sides are parallel. Opposite sides are parallel because of the definition of a parallelogram. So we're just going to verify that with the slope formula. So down here we have the slope formula. We're going to subtract our y's on top and subtract our x's on the bottom for each set of points. So starting with AB, whenever I'm finding slopes, I like to use the one on the left as x1, y1, and the one on the right is x2, y2. So as I set this equation up, it's going to be 0 minus 0 over 7 minus 0. So that'll simplify down to 0 divided by 7, which is 0. So the slope of side AB is 0. The side that is opposite of AB is side DC. So again, I'm going to use this as point number 1, and this is point number 2. And I'm going to do 4 minus 4 for the y values, and then 11 minus 4 for the x values. And that's going to be 0 over 7, which is 0. So since the slope of AB was 0 and the slope of DC was 0, AB is parallel to DC. Now we're going to look at the other sets of sides. So we're going to look at AD first. And for this one, I'm going to use D as number 2 and A as number 1. So I'll have 4 minus 0 over 4 minus 0. So that comes out to 4 over 4. So the slope of AD is 1. And then for CB, I'll use C as number 2 and B as number 1. So that'll be 4 minus 0 over 11 minus 7. So again, it's 4 over 4, which equals 1. So since the slope of AD was 1 and the slope of BC is 1, AD is parallel to BC. So both sets of opposite sides are parallel. In the next part, it says use the distance formula to show that opposite sides are congruent. So when we're talking about distance formula, we're talking about the Pythagorean theorem, because the distance between any 2 points can be thought of as like the difference in the x values and the difference in the y values, and that makes a right triangle. So we're thinking about a squared plus b squared equals c squared, and then that distance, that's the hypotenuse of the right triangle that you draw. So that distance, we can call this d. D equals the square root of a squared plus b squared, where a is how far apart the x's are, so the change of x, and b is how far apart the y's are, so that's the change of y. So if I'm looking at the points a and b for that side, to come up with what's going underneath my square root, the first number that I plug in for a is how far it is from 0 to 7. So in between 0 and 7, that is 7 units. So this is going to be 7 squared plus, and then I'm going to look at my y values. So 0 and 0, those two are no units apart. So it just becomes the square root of 7 squared, which is square root of 49. So whenever you only have one length that has any value, that's actually the length of the entire segment. So the length of AB is 7 units. For DC, we're going to use that same process. So I start with my square root. The first number is how far it is between your x's. So from 4 to 11, that is 7 units. And then from 4 to 4, that's 0 units again. So we end up with the same thing. So the result is that the length of DC is 7. So from that, we have AB is congruent to DC because they're both 7 units. So now let's look at the other sides, the other sets of opposite sides. So we start with AD, and for AD, the distance between the x values from 0 to 4, that is 4 units. And from 0 to 4, that's 4 units. And 4 squared is 16. So 16 plus 16 gives me 32 underneath my square root. And so I can estimate it. I could simplify it, but really, if the other one comes out to the square root of 32 as well, I already know that they're congruent. So I'm just going to leave it like that for this time. All right, next I'm going to look at BC. So between my x values, I have to go from 7 to 11, which is 4 units, so that's 4 squared. And then from 0 to 4 is 4 units. So I already did the math because this looks just like the other one, and this is also going to be the square root of 32. So since they have the same measure, they are going to be congruent. So using the distance formula, we were able to show the opposite sides of this parallelogram are congruent. The final thing we're going to do with this is we're going to think about those diagonals. So our theorem said that if it's a parallelogram, then the diagonals are going to bisect each other. And so we have to think, if the diagonals bisect each other, what point should they share? So let's think about one of these diagonals. If I just think about diagonal AC, and those two diagonals intersect at point E, what should be special about point E? So if this is a bisector, then both sides would be the same length on each side. And if that happens, then that means that E would be the midpoint of this line. So if we bring in the other diagonal, it's also bisecting that line. So E should also be the midpoint of diagonal DB. So we're going to check and see if these two diagonals have the same midpoint. So to find the midpoint of a line, we have the midpoint formula over here to the side. That's where we add up our x's and divide by 2 because we're trying to find the middle. It's like we're averaging it. And then we do the same thing to the y's. So let's start with diagonal AC. So if I'm using A and C, what I'm going to do is I'm going to take my x values, 0 and 11, and I'm going to add those together and divide by 2. And then I'm going to take my y values, 0 and 4, add those together and divide by 2. So as I go through and simplify this down, first I have 11 divided by 2, which is 5.5. And then I have 4 divided by 2, which is 2. So the midpoint of AC is at 5, 2. We're going to do that same thing with segment DB. So I take the x values 4 and 7, and I add those together for the x and divide it by 2. And then I take the y values 4 and 0 and divide it by 2. So as I go through and I simplify, I have 11 divided by 2, which is 5.5. And I have 4 divided by 2, which is 2. So since AC and DB both have a midpoint at 5.52, the diagonals bisect each other. So using the midpoint tells us that it's directly in the middle of those two instead of having to find all 4 of those links and compare the links. The midpoint does the same thing. So that's all the properties and how we can use them for those parallel.